probabilistic side to these things, but I don't study. You know, it's difficult. Just so you know, if you're a CS major, when you start adding probability to algorithms, it gets complicated. The story gets a lot more complicated than if you just talk about worst case. If you talk about average case, usually it's really tough. And why would it be tough? Some of the simple algorithms, they have subroutines or whatever it is. They just have or they do something with the data structures, like recirculation of stuff, and it's hard to keep track of where things are going. You know, to make a probabilistic analysis. Okay, so
yeah, it's like complexity arising out of simplistic like rules.
That's kind of a deep statement.
Sorry.
It is. I mean, that's kind of a deep statement. I tell you, yeah. And then sometimes the complexity is whatever. Yeah. That's. I wasn't even thinking about that. I was just thinking about like, I don't know if you're familiar with the heap sort algorithm. That wasn't analyzed well. That wasn't analyzed probabilistically until, you know, it was open. It's an open thing for like 40 years or something, and it was one of Knuth's problems. He has a list of problems that you get a check for if you do. It was one of them, and you know, to get the second order terms in the expected time that it takes is probably very, very difficult to do. It was done, but it was hard.
That's really cool.
Yeah, but I hate to say this. I really hate to say this. I'm working on myself on the exact median complexity problem, not the probabilistic one. And I have this feeling that the interest in the thing, the beauty of it is in the worst case, not in the average case. It's just a feeling I have. So yeah, it can be, probability can be neat sometimes, it can be ugly other times. Okay, so let me try to get my brain from algorithms into conditional probability, and let's see how this goes. Let me try to warm up, okay? And I don't know if we did this yet. I don't think so, but if we did, just forgive me for forgetting that. So this is exercise problem 3.11, just as a warm up. So first of all, are there any general questions I should check, or if the exam went? Should I say anything about the test? You know, you should be graded. You know, I try to submit all the grades. Almost everybody took the test. The distribution of scores, numerically anyhow, was bimodal. And I think you guys understand that means, right? There were two peaks. There was a peak in the 30s or something, you know, above freezing, but still, you know, unseasonably cold. And then there was another peak like around 80 points. So I don't know if there's anything I can say that improved the situation, but I did urge the people that didn't do as well as they could have. I urged them to join groups, to join up, you know, to band together, you know, band of brothers, so to speak, or something, a band, right? A tribe, you know, get tribal about it, you know, whatever. But it wasn't because they were loners. It just seemed like they felt that maybe they wouldn't have that much to offer. But since there's so many people in that category, you guys could all band together and be a super group, you know? You know what I mean? I felt like the results were much stronger on the test for groups. And I say stronger, when you're in a group, there tend to be fewer silly mistakes, you know what I mean? Like just arithmetic error or something like that. I guess I've been through all this before, but definitely was strikingly bimodal. And that's devilish for a teacher, because who do I lecture to, you know? And if you split the difference, you end up in a desert. And I feel like I have to, well, we'll just do what we're doing. But I feel like if I was to lecture to the lower peak, then the course might be more like Math 140 and less like 340. You know, nothing wrong with 140. I used to teach it. It's a good class. You'll learn a lot in there. But that's not my focus. It's, you know, GE Math is not anyhow. It used to be, but not now. Okay. Any comments, concerns? You know, forgive me about yesterday, whatever it was, Thursday when I was out to lunch. You guys okay? Awfully quiet today. Maybe have some resentment about what happened. No, I'm kidding.
No, we got our grades. If anything, one of some of our group members, we just kind of want to see comments. But if you don't have those, then don't worry about it.
Oh, I'm fine to do it, but if you could come to my office hours, then I could break it down,
Sure.
I did do some weird things because one of the problems had 3 parts. One of the parts was a C part that involved words, English words. I just didn't grade that. I just graded the first 2 parts because it really depended on how many English words you accept there. You accept 6 or 4 or 5 or whatever, So that was one odd characteristic of my grading. But I remember your paper, and I don't recall there being any weaknesses in it. It was very strong. The problem with these original style questions is that 80% of the battle is understanding what it's asking, and then the math part didn't seem to be. Once we got that down, the math part seemed to be pretty easy for some people to do. And I'm thinking that on the next test, I would encourage anybody who's having trouble understanding getting in the right ballpark, so to speak, right, to email me and say, look, Donnie, I don't understand what you're asking. It just doesn't make any sense to me. Don't be shy about that asking, because believe me, I'm not the fastest learner in the world, and I've been so often in the wrong ballpark. You know what I mean? So I get it, and I'll definitely try to help people get settled into wherever the problem is, so they can attack it with some math formula or something. Of course, that kind of deflects your question about what were you looking for? Maybe you were looking for me to say whether logical.
Yeah, I think just going to office hours would be fine.
Okay.
Yeah.
But it seemed to me you guys had it. You absolutely had it. Your group, anyhow.
Mm-hmm.
But maybe you're not speaking for your group. You're speaking in general. I don't know.
Yeah, just in general, I am.
Because there was a student, well-meaning and so forth, and I encountered him in the office hours, and he had me do every problem in the test one after another. And I swear to you guys, I'm not kidding you, I was about to drop. It was my 4th shot, and those problems on the test are not easy. So I had to be with it to do it. And I was about to drop, and I kept telling him, I don't think, I'm not sure I'm going to make it out of here. So just human, you know what I mean? It's better if a student comes with me and says, this is what we did. I'm not sure why it's wrong. Something rather than just do the problem for me. I don't know. You guys are probably thinking it's impossible for somebody to drop from only 5 hours on their feet, but I'm just not used to being on my feet this long. It's just, I guess I could work up to it, but just not used to it. Okay, let's take a look at this warm-up problem here. So you pick 2 cards at random. Hopefully I can do this. Pick from a full deck. So you pick 2 cards, and B is both cards are aces. B for both. Both cards are aces. Aces. And ace of S is the ace of spades is one of them. One of the cards. It's picked. It's one of your 2 cards at random. And A is this crazy definition, at least one ace is picked. At least. That makes it difficult. Is picked. Okay. I claim this is not a hard problem, but that really depends on how you set it up. There's multiple ways of setting this up. So what are they going to ask? What are they going to ask here? They want to know what's the probability that both. Let's see if I have space to put it in. It's a probability that both are aces. Oh no, I'm going into a bad zone here, a slowdown zone. Oh my gosh, what's that stupid song? It's from the 50s. Okay. Anyhow, sorry. What's the probability that both are aces, given that one of them is the ace of spades? Okay, how do we do this? So one of them is the ace of spades. What's the simplest way? There is a simple way to so you've picked the ace of spades, and you now, okay, so ace of spades has been chosen. Now you pick another card. How many cards are left now? After you pick that one card, we got to remember we're dealing with a full deck and no jokers. So we can think of this, the reduced sample space is what? You've picked the ace of spades, you're picking another card now. Out of how many cards are you picking? It's quiet. How many cards are in a full deck? If we're dealing with a full deck, how many cards?
52.
52. That song goes, right? If you can't remember, that's a deck of 52. That stupid 50, 60 song. But anyhow, so we just picked one already, right? So that means there's 51 left. And in those 51, the other aces could be anywhere. So how many aces are out there to take?
Well, 3 left.
3, right. So this is the probability of picking another ace after you pick the ace of spades. So now it could be anywhere in the 51 cards, but to pick another, there's 3 shots. This is using the reduced sample space approach to this. This is the A part. Now you might say that I didn't do anything. Where's the formula and all? Well, if I'm thinking of the reduced sample space, the ace of spades has been chosen. What's the chance that the next card's an ace? Well, that probability is 3 out of 51, because there's 3 places where it will be. There's 51 possible, places it could be, but the 3 of them will be aces. So the probability of picking an ace, given that one's already gone from the deck, is 3 over 51. Is that okay? Somebody's got a chat, right? They didn't see what they said. They said 3. Good. Yes. Okay, I'll stop for a second there. So really, because this shows up so often, we should simplify. On the test, sometimes people would simplify, sometimes they wouldn't. Sometimes they would use a decimal, sometimes not. Could you guys, on the future, just to save me having to go to my calculator a lot, could you just give me a decimal on your answers? That way, otherwise somebody gave me this compound this fraction, right? And I had to, calculate what it was. I didn't recognize that as being an answer.
Just put that in the just in the instructions.
There's so many instructions.
Not everybody's here, so just to have.
Are we missing somebody? We're not missing that. Well, yeah, few. Yeah, is there some sort of sporting event? No, I'm kidding. Wishful thinking, right? Wishful thinking. Okay, I'm trying to get warmed up, and this next one is really more than a warm up. Okay.
Quick question.
Yes.
So the 3 over 51 is the odds provided you already got one ace.
Exactly. This is the reduced sample space here. You've picked an ace, so there's 51 cards left, and amongst those 51, among those 51, there's 3 that are still aces, right? Because you got 4 aces in the deck. This is Ross calls this the reduced sample space method. It's simpler than we could have written this out and gotten a ratio of probabilities, and this is a lot simpler. So his next one is complicated. It's complicated, and I really need more space to do it. So sometimes if there's a B part, it uses the A part. I don't think it uses the A part here. So let me just erase this and put in what we need. Okay, so I just got to make sure I don't go into okay, so the B part is probably that they're both aces, given that what was A? At least, here's that crazy, at least one is an ace. In this case, I don't, it's not obvious to me how to knock this off with one step, so I think I need to write the definition of conditional probability here. How do we do that? So this is the probability of BA, Bernstein Appleby, over the probability of A. Now let's see if we can do anything with this. Let's see if we can simplify what we have. So this is the probability least one ace, this is the probability of getting both aces. Those are two events, right? But they have a certain property. So there's the intersection of two events, but one of those is properly contained in the other. So therefore, what is this going to be? What's it going to be? Well, let's see. We got to think about this logically. The event that both are aces and the event that at least one is an ace. Which one is more restrictive? So you got two things. One of these events sits inside the other. I think you guys know, but I just...
Would A be a subset of B? So we could reduce it to just the probability of A?
Well, okay, let's draw a picture. Maybe this will help. You got the idea. So here's A, right? This is the event. At least one of them was an ace, right? Now, if you look at B, but both were aces, you see that everything in here they're both aces, right? But you definitely have, it's true that at least one is an ace, right? So maybe that's what you said, but B actually is a subset of A.
Yeah, I just had it reversed.
Okay, no, you're okay, but you had the idea. This is a minor step towards victory here. I hope I can achieve victory with this problem. Okay, so now I have trouble because I've got to calculate. So what would be the probability that I picked two aces? So let's see. So how many ways can I pick two cards and they're both aces? I'm trying to evaluate P of B here. How many aces do I have in that deck? I've got 4, right? So how many ways can I pick 2 of them? I know you know. Aim, I can see your face. I know you know. I know now. Now I know you. I know you kind of like. I can see that. I wish I could take a screenshot of that.
I'm trying not to say.
I know.
That's
But it's
wrong.
like I can read your face like a book. It's like perfect. It's like perfect. Okay, so it's okay. 4 choose 2, and then over what? So well, we're talking probability here, right? How many ways can I pick 2 cards from a full deck? 52. Choose 2, right? And of course, I wrote it so that nobody can read it, which doesn't help anything. So 52, choose 2. So that's what I got in the numerator. The bottom now is a trick, okay? The bottom is, this is why this is a legitimate problem. They're all legitimate in chapter 3. It's a very difficult part of the book, right? How am I going to do the bottom? What's the probability that I have at least one ace? What's the probability of at least one ace? What's a better way of thinking about that? If you have at least one ace, the probability is going to be 1 minus what? The probability of what? What's going to be?
Not having an ace.
Yes, it's going to be 1. What is the probability of having no aces? Sounds like having an oasis. No, but that's different. Okay, so it's what? Well, you have these 2 card hands from how many cards? You can't pick any aces, so how many cards are left after you deduct the 4 aces? 48 choose, sorry. So 48. So it's 48 choose 2 over, and we're dealing with probability, so 52 choose 2. Okay, now the fun comes. So this is probably getting oasis. It would be those hands that have none, which would be 2 of the 48, and here is just all hands. 52 choose 2. Now I've got to get an answer out of this. Yeah, question.
Sorry, I'm a bit confused as to what we're doing in the
okay, let me help.
denominator.
Yes, let me show you what we're trying to evaluate. We're trying to get this right here. Okay?
Right.
Now I claim that that's equal to this.
Yeah, that's what I'm not following. I must have zoned out.
Well, that's okay. Think about it. You want the probability of at least one ace, right? So that would be one ace or two aces, right? What's the complement of that? What's the complementary event? So in other words, if it's not true you have at least one ace, then you must have
Oh, okay, I see what you're doing.
none. So that would be 1 minus the probability. So this is the none right here. 1 minus the probability of no aces.
Okay, I think. Yeah, I see what you're doing. Okay.
So we're really going to take the complement of this, and the complement of a complement, the probability of a complement is 1 minus the probability of at least one ace. Is 1 minus the probability of this is no aces here. So okay, so the fun comes now because what? I've got to do some arithmetic here, and I recall it being hard. So what would be a good way to simplify this? I know I've got a 6 on top. And what do I have in the bottom? So I'm going to multiply top and bottom by 52 choose 2, which is what? 51. So 50 times 51 choose 2. There's a 2 there. And then it's minus 48 times 47 over 2. I'm glad I have notes because I'm not good at this kind of thing. So this is 12. What do we have here? I guess I need to do some calculator nonsense. 52 times 51 minus 48 times 47. I don't know what that is. I guess I could try to simplify this. Does 12 go into this? Certainly goes into here. So 12 goes into this how many times? This is 3 times 17. And this is, what is it, 4 times 13? So,
Oh, yeah, so 13 times 17 minus.
I hope so. And 12 goes in there 4 times. I know that much. I don't know.
Yeah.
What's 13? I don't know what 13 is. I don't know what it is. Okay, I have to use a calculator. I can't do it in my head. I should be able to do this, but I don't know. I mean, is it even right?
I'm getting 0.0303.
Yeah, but let's try to get it as an exact. So what do we got? We got 1 over. What is 13? I just got to do some. Let's just do a little calculator stuff. I can't cheat it and say, oh, I know what it is, because I don't.
1 over 33.
Times, thank you, Aim. That's 33 in the denominator. Why didn't I know that? Okay, it turns out it's a simple. Yeah, you might wonder, that's such a simple number. Maybe there was an easier way to do the problem. I don't know. I like this method. And I think there's harder ways to do the problem. But this is the way this makes sense to me anyhow. Thank you, Elizabeth. That's right. Okay. Any question on this? This seemed like the hardest part was this arithmetic. So I'm not good at.
It took me a minute to understand how you like that bottom, the beginning of that bottom line, but now I see. I mean, I figured it's what you were doing, but I know what you were doing, but it took me a minute to realize why it was correct.
We're talking about this or about down here?
Down there,
Oh.
the beginning of it, like you multiplied the top and the bottom both by 52 choose 2.
Yes.
Right. So and so then you just end up with the 4 choose 2, which is 6, and then the 1 basically turns into 52 choose 2, and then you kind of wrote it out there. So now I get it.
Right. I wish I could have had more space in a normal classroom. I would put more details, but this is actually the limit. I tried writing on the brick, but it didn't. Okay. So I'm limited in how much I can write. So yeah, that might have been confusing.
That 4 times 47 in the denominator, or what is that?
4 times, because I divided a 12 into 48. That goes in 4 times. So the 12 goes in here 4 times, so that's
Okay.
4 times 47. So 1 over 13, yeah, go ahead. I promised you, the arithmetic on this is daunting, right? Okay. Are you good with it now? I had to use a calculator on the denominator. It's 33. All right. Okay. Are you guys okay? So we can go on to the next. The last thing, this is the last problem I'm going to do in this section of the book. I don't even know if I'm going to do it. Sometimes all right, okay. So this is the gendarme at the gate. So the bugaboo. So we're going to try to do the last problem for this chapter, and it's very difficult, but not hard because it's so many steps. But we have to be careful about what we put in. So I'm going to look at 328. So I can erase this. You guys are comfortable with this? Okay, I assume so because I'm not hearing anything. Okay, so as with all decent problems, we have to we've got to get ourselves into the ballpark. And, I would be the world's biggest liar if I told you this was easy what we're going to do. It's innocuous. It's 328, so 328A. So you might be thinking, how could it? 3.28A, how could it be hard? Let's see what they're asking here. So you're going to lay out the card from a shuffled deck. You're going to lay out the cards. I can't write this in English, okay? You can read it in the book. I just cannot do it on the board. I have to show you what it is. Bill, does anybody have the textbook with the 9th edition? Yeah, you guys. Can I just ask you guys out there? You were able to find it, right? Download it without having to pay a lot. Just somebody. I thought there was a link or something. Help me out, you guys. Can you get it? You guys, did somebody buy the book? Right. So, but if you're in the Discord, Bill, if you're in the, we've got a link there. Okay. I think he is, right? Okay. Let's go back to the problem. So, how does this work? How does it go? What is the situation? You're laying out your cards, and on the 20th, here's position 20, and here's position 21, and you keep going to position 52. This problem asks a very interesting question. So you lay them out one at a time. You lay them out here, all 52, okay? That's the experiment. Shuffle and lay them out. Now they're asking you something interesting here. Limited space, you have to follow me. So I would like to know the probability that the ace of spades is here at position 21, given that some ace has occurred. The first ace has occurred in position 20. Now, this is the critical thing for this, okay? And I have limited space to write this. So, ace of spades, what does the event ace of S mean? Ace of spades in position 21, when you lay them out. A1 is the event that the very first ace, it doesn't matter, it could be the ace of spades, occurs in position 20. This is a bit of a mouthful to say what's happening here, but can you visualize somebody taking them one at a time from the deck, laying them all out in order as they came out, And we want to know what's the probability that we have an ace of spades in position 21, given that some ace, the first ace that occurred, happened in position 20. I'll stop here a second. Do you understand what's being asked? There's a lot in there, but I'm not going to write it out because that's not going to help. Think about it this way: it's a conditional probability, right? Another way to say it is, given that the first ace occurred at position 20, the first ace. What I mean is, there's no other ace going up from 1 to 19. The first ace occurred on 20th position. What's the probability the very next card to come out is the ace of spades? I'll stop there for a second. Can you understand that this is can you picture this happening? Somebody lays out 20 cards, and the very first ace that comes out is on 20 in the 20th. And then somebody says, hey, what's the chance that the very next card is going to be the ace of spades? This is the real thing from chapter 3, okay? This is a sandbagging problem for people that think they know this stuff. Now, look, if you're struggling with what to do next, join the club. I was struggling too. But what do you think would be, considering what we've done so far, what do you think would be a logical next move to try to evaluate this expression, this conditional probability? What do you think would be something we could do next? Even if you're not totally clear on the problem, what would be the next move?
Well, for me, I would break it down on what this depends on. And one thing it depends on is that no aces have shown up for 19 cards, right?
Exactly, right. But I mean, what I was trying to get, Ethan, was not the overall mental picture, but just if you were a computer just chugging through, what do? We usually just write out the definition. That's what I was looking for, right? We don't even have to think. We just write it out.
Condition it out, or
just write it out. So what does this mean? What does this mean? What does this notation mean? We have it mathematically. We know what it is.
Professor?
What's in the numerator?
Professor?
Brandon?
Yeah, does this factor in if there were any aces before the 20th?
Well, okay, we don't have to. Okay, that's an excellent question. What Ethan's saying is excellent also. The thing is, the reason why we have these formulas is we can proceed without having to think about it. Once in a while, we have to think. But a lot of this, the goal is just automatic calculation. And I have seen actuarial exams, actuarial 1, right, on probability. And all of those problems, even though they're not trivial, none of them are trivial, but they all can be attacked by simply just apply a formula. But what I'm asking you for is the definition of this, so we can just we can break it down. So what is this? What is it? Just define it. What is it? So this given this is what? What's the definition?
Wait, what's that subscript say?
Ace of S. It's just an event.
Oh, okay.
It's just an event. It's the event that you get an ace of spades in position 21. It's just an event. An ace of 1 is, well, the reason I used a 1 is that's because this is the event that the first ace to show up occurs in position 20. But we don't have to think about it. If these are just like events AS and ace of 1, what does the definition tell us? The definition of this. What is
it? A sub S, I want to say, I hate just saying A sub S, A sub 1, but that's what it is.
That's what it is. Yes.
Intersection with it. That's right. That's the word, right?
Right. You can use and. I usually use, and for the intersection. Of course, my writing skills.
Well, technically, if it's set notation, you wouldn't use and, right? You would use like the little.
Unhappy face. We don't want unhappy face.
The intersection symbol.
Right. But it's and. In this, like A and B is you have to have both, right, to have A and B. So, okay. What about this? What's in the bottom?
I mean, it's analogous to and.
Okay.
That would be probability of A sub 1. Good. Let's
keep going here, because when I did this at home, I found it useful to switcheroo the conditional probability. That's just the way I am. So if I switcheroo, how can I write this? I want to switcheroo here, the top.
Okay, probability of A sub 1 given A sub S.
Oh, okay. So how about A sub S? We use the general product rule, right? Times the probability of A sub 1 given A sub S, okay? Over what? All right? Oh, somebody's trying to call me. Okay. That's just the definition. We just switcherooed because it was convenient. Now comes the battle, right? We have to evaluate these terms, and we have to do it carefully. Otherwise, we'll be in for a long 2 days of struggle. Okay, So what's the easiest? What is the probability that this event, that the ace of spades lands in position 21? What is that probability? Is there anybody that doesn't get that? You laid out all the cards, you shuffled and laid them out. What's the probability that a specific card landed in one of those spots, but in particular in spot 21? What is that? Is there anybody that doesn't know that? It's quiet, so I don't know whether that's...
I'm struggling to remember how to do things right now.
Think about this, okay? You lay it out, right? You when you shuffle, everything has its order, right? When you lay them out, you see what that order was. But when it's shuffled, the ace of spades could be anywhere in that deck, right? So to say that, what's the probability that it's in a particular place in the deck?
Oh.
That should be obvious, right? I mean, it's like, if there's 365 birthdays and I don't know your birthday.
Yeah. So it's 1 out of the number of spaces.
So and knowing your birthday.
1 out of 52.
My guess, you see, if we didn't have leap year, if I just get, oh my gosh. If we didn't have leap year, my guess on your birthday will be 1 over 365, right? Okay, let me continue that thought process, okay, for the next test. If I took 2 people at random, okay, suppose only 365 birthday, 2 people at random, what's the chance that they both have the same birthday? And that one's for you.
I think that's 1 out of 365 again.
You're right. Did you get that? You good? Okay. Well, guys, you know what? You guys have done your work, and I got to say that. I have to say that. Very good. So you're not going to be okay. But so we can fill in one of these things, right? It's 1 over.
Okay. Yeah. The way I like to think about it is you're just looking at the one spot, that 21st card, and so if you want just one card, that's 1 on top, but there's out of 52 cards possible.
Yes.
So don't think about it too hard.
Unfortunately, I have to be honest with you. This is something about this is very difficult for me, this problem. And I remember I used to, when I was younger, teach graduate classes, and there was a problem that was sort of hard in there, in the textbook, and somebody cracked it, and he walked twice around the perimeter of CSUN to celebrate the fact. So this is kind of like that. This is a hard problem. I don't know if anybody's going to come to school and walk twice around it to celebrate, but that's 1 over 52. Now comes the hard part. Let's think about this. What is this saying? This is the probability that you hit your first ace in position 20, given that there's an ace of spades that's immediately following it. Okay? We have to think about this. How many disjoint cases are there? The ace of spades is covered in position 21, right? How many aces are left?
Yeah, reduce sample space. So there's 3 aces left.
3. So we can multiply by 3 because it will be the same probability whether it's ace of diamonds or ace of clubs. Okay, but 6. Now at this point, 2 aces. After the 3, 2 aces have been determined. Ace of spades and whatever that is, ace of diamonds. There's 2 more aces, and these 2 aces can come out of where? I claim
51 cards,
no,
right?
but you see no aces.
Oh, 31. Oh,
no aces here. So we got to think of where can they come out. Well, I kind of know how many spots are here. So it's 52 minus 21 is known to be 31. So that's, now there's something missing which bedeviled me last night until I was just fatigued and I couldn't think straight. But we've chosen the spots for the two aces, but there's two ways they could go in, right? Ace of diamonds first and then aces with clubs. There's two ways. So you need to multiply by 2 here. Now I need to fix the rest of the cards. So how many cards have been determined now? You got your 4 aces, right? So the other cards can go in 48 factorial over 51 factorial ways. This is so there's 51, because why do I say 51? Because I know the ace of spades is here. So the rest of the cards, so there's 48. So this is where you use your reduced sample space here. Reduced, that's why it's a 51 factorial, not a 52 factorial.
So why can't we just, well, maybe we can, but I'm not sure why we're not just, why we're not saying 32 instead of 31.
Oh, because, okay. Because there's actually 31 spots here. We've got this ace and this ace. This 3 means we're into one of those spots where this is like ace of diamonds, ace of spades. So now the remaining 2 aces must live in this. We're counting all the possibilities. They must live amongst those 31 spots, right? So
Okay, I'm not quite sure how you're setting it up now. Sorry.
Well, I'm evaluating this right here. Okay, we're assuming that the ace of spades is here. So that's set. That's fixed. That's your reduced sample space. Okay, so
yeah, I get that part. So
there's three possibilities for this. There's 3 possibilities for this ace. Those are separate, disjoint sets.
Oh.
We can take those probabilities separate. They're all the same number, so we can just multiply by 3. There's 3 possibilities. This could be ace of diamond, clubs, or hearts.
Okay, I get it. So you're saying it is an ace. Okay, now I get it.
Yeah, it is, and that's the reason for the 51 factorial. But let me just try to get the bottom. Okay, so the bottom goes like what? The bottom is saying, what's the probability that your first ace occurs here? There's no mention of the ace of spades. What's the probability of first ace? Well, there's 4 different possibilities for that first ace, right? And the other aces can be distributed now into 32 spots. And how many aces are we talking about here? 3. And I need to multiply by 6 because that's 3 factorial. They could go in those different ways. And the rest of the cards, or there's 48, they could go in any order. And to get a probability, I divide by 52 factorial, okay? Now, I'm running out of space here.
Okay, I'm sorry, I'm like way...
Well, let me get an answer, and then we'll backtrack, okay? Because it turns out that it's not trivial to do the arithmetic here. So it turns out that this is equal to, there's a 3 on the top. See that 3 right here? There's a 3 on the top, and if you look at the 52, it's going to cancel with the front end of this 52 factorial. So all that gets left is 3 times 31 times 30 over 32 times 31 times 30. So this cancels with this. And there's a 4 down there. There's a 4, this 4 right here. And those cancel, and then you end up with a 3 over 4 times 32, which is 128. That's the right answer.
Wow.
Okay, so how do we get this? You're probably looking at this. This is actually simpler to calculate than this. This is the probability that the first ace occurs at position 20, okay? So you would be looking at all possible, orders of the cards, okay? That's why you get a 52 factorial. Now we're counting those where the first ace occurs there, so this handles all those cases in which the aces are located. But remember that there's 48 other cards. It could go in any way they want, and you would still get the first ace occurring in position 20.
Okay, so
Okay,
I'm
you know what?
I'm still confused on the numerator. Actually,
Oh,
what did the 48 over
this right
51
here.
come from? What's
Okay, but
that?
you're good about this. You're good about this, right?
Yeah.
Okay, from a general standpoint, look at it this way. See all this junk here? This junk here? That's just locating the two aces, the two remaining aces you have. It's just locating them, right? Different places they could go. But this is the orders for all the other cards. We're assuming the ace of spades is in position 21. So that means that the reduced sample space is 51 factorial, different possible, equally likely possibilities. So this is, if you look at that central glob here, that's just locating your aces. So that you satisfy the fact
Okay.
for the first one. Yeah, so that's okay. What's not okay is this the arithmetic.
I'm sorry. So I just it's 48 factorial over 51 factorial. That's
okay. How do you get this?
That's arrangements of all the remaining cards that are not aces.
Yes. And you see, you fix the ace of spades, so that's not arrangeable. That's fixed. So that means you have 51
all the
other
other
cards
ones
that
are arrangeable.
Yes, could go anyway, right.
I think I get it. It's a little hard for me to think of.
The interesting thing is, there's something a little bit interesting about this number, but if you factor it, what is it equal to anyhow? How do I factor 128? It's 2 to the. It's 32 times 4, or something like that. 32 times 4. So maybe it's possible to do this another way, and then you could exploit the fact that, hey, I've got this this looks suspiciously simple compared to all this work it took me to do. Okay, let me move on because I want to have you guys go home with something interesting. This is what I'd like you guys to do as part of your homework. First of all, go over this and spend the quality time to try to get comfortable. But there's some other issue. This problem is the A part. The B part is even worse, okay? And we'll just take a quick look. I don't want to put all the steps in. Maybe I'll leave that to you to work on, or talk about it with me during office hours. The B part, how do you think the B part is going to work? Then the B part, they don't assume the ace of spades. They assume the 2 of clubs. This is even harder. Okay, this is going to be even harder. Same argument. You set it up the same, but it's not so easy. So I think we should give names for these. So this is your first ace here, and let's say, so this is saying that the 2 of clubs, let's call it 2 key. The 2 of clubs appears here, given that the first ace appeared at a location 20. Now maybe I owe it to you to just spit out the answer. In fact, you know what? Something's weighing on my heart. I need to spit out the answer so you guys can follow it, okay? Because it didn't happen instantly. Let me just spit out the answer for 328B, and you guys can finish it or try to go back and re-engineer it, back engineer it. Let me give you that, because I think it would be unfair if I did anything else. It's not. Okay, so now let's understand the situation now. Same problem, no aces in the first one. No aces up to number 20, first ace appeared there. And then this, we're asking what's the probability that guy, the 2 of clubs, immediately succeeds that first ace. And I use ace of 1, I don't know, it's just by, as I said before, that's the event that the first ace occurs at position 20. I mean the first, 1 for first. Okay, so let me just write this out. So this would be probability of 2C times probability of A1 given 2C over probability of A1, using the same kind of stuff we did before. And now this is where it gets wild, is when I start substituting in. hope I haven't put too many people to sleep here, but you know what? I think it's at least superficially it's interesting. So this part we can do, right? The probability that the 2 of clubs is in position 21, that's 1 over 52. We did that before. And what? Now comes things are a little bit different. There's 4 cases. What are the 4 cases? Since the ace of spades is not showing here, that first ace could be 1 of 4 now, not 1 of 3. Because this is 4 times 31. Now this is the other aces, where they go. And why is this 51? Choose 3, because I've already fixed one of the aces here. And this is all over. Okay, now the first ace, there's 4 ways that first ace could show up. The other aces have 32 locations they can go to. Don't 52 choose 4. There's something missing here. When you multiply these things out, there's obviously some cancellation because I get a 6 here and I get a 6 here. They cancel, so I don't worry about that. But I think there's something between this 3 and this 4 that could cause a problem. But it turns out I did this. Just giving you the answer, it's 29 over 1536. Okay, so there's obviously something. How is this 4 handled here? This 4 factorial, but you see this 4 will kill one of those. So you end up with a 3 factorial 6. And some, you'll be able to cancel that out. 2 things cancel out, and you end up with 29 over 1536. Alrighty. Okay. Some people say it's unteachable. Conditional probability is unteachable. And I think it's a question of motivation. If you're going to go the actuarial route, you will master this much better than I'm doing right now or trying to do. So I think it's just reps. You have to put a lot of reps into these. When I say rep is you solve this problem, then a day later, without looking at the notes, you try to solve it, and you'll get stuck somewhere. At least I would. And that's the thing I need to focus on. So when I say reps, I mean, you might say nobody does that. Well, I do it. If something in my research, I'll prove it over and over again, like 20 times until I really, really am comfortable with it. Maybe that's a math thing and not a CS thing. But you think about this. We're learning a language.
I'd say it's an everything thing. I mean, there's certainly, I forget how to do stuff or like what I was doing if I'm programming something and then I go back and look at it later and I haven't done it for a while. I'm like, what the heck was I doing?
Well, I hear you. Some people are not, okay, some people don't buy into these conventional wisdom things. But I don't know if has anybody studied the Beatles at all? I mean, it's probably way before you guys were born. But they're a classic example of some psychological theory that you don't learn something really, really well until you've done 10,000 reps. So people wonder, did the Beatles really work that hard? Did they do something 10,000 times? Well, they actually did. And if you look at their old recordings of them performing, they didn't make any mistakes. And I don't know if you listen to music,
That's so cool. I love the Beatles. I was like obsessed with them as a.
But if you look at music, that like on the Late Show or something, something like that, that's live, like what the Beatles did. If you're a musician, you listen carefully, you will see mistakes, now and then that are made. They're awfully good. These guys are professionals. But there's this concept, you have to do something 10,000 times to master it. And it's sort of like, a lot of people say that's ridiculous, just show me how to do it, I'll do it, I got it. Well, there's different levels of understanding. And I think with math, my opinion is reps really count. And you got to do a lot before you notice the difference, unfortunately. It's very time consuming. With my research, it took me over and over and over again. It's embarrassing how many times I had to do the same stupid problem, to get it. Okay, so let's do the last thing here, something interesting, okay? So this is the next chapter. So it's called discrete random variables. And I'm sorry, I'm using using abbreviations here, but it's chapter 4. So what is a random variable? It's not a variable. It's a function on the sample space, okay? It's just a function on the sample space. That's all it is. So I'm going to give you the best example I know right now. Okay, so this is the problem where the sample space looks kind of funny. The sample space has numbers in it, and the numbers indicate how long a certain restaurant stayed in business. Okay, now we all know that restaurant business is the clientele is very fickle. So let me tell you the truth of the matter. For a bad year, there's a 40% chance of a bad year. I don't know what you mean. Bad year means you're probably losing money, and so you have to take some loans. So therefore, you have a 60% chance of a good year. Okay. Now, just based on what would the sample space be? The sample space would be a number of how many years you went before you went bankrupt. So can you tell me what's the shortest amount of time it could take before you go bottoms up on this? Tell me.
2 years, because it's too bad.
Yeah,
2 years, isn't it? Okay.
Yes, exactly. Very good. And could you tell me the longest?
Forever.
It could be forever, right? It could be forever, okay? It could be forever. So this sample space is infinite, but it's not infinite in a bad way, because it's sort of countably infinite. You know what I mean? These are sequences. It's countably infinite. They all end in 2 bad years, but it's countably, when it's countably infinite sample space, then, or finite, then you call it a discrete random variable. So the question is, this is a $64 question. How long do you expect to stay in business? How long? Okay, so now it's time to, it's time to now use your intuitive powers, which I know you guys have, because I've seen it in action. So somebody just tell me now, how long do you expect to stay? I want a number. I want a number now. Just take a guess. How long do you think you can stay in business? In case you weren't paying attention, the only way you go out of business is you get 2 bad years in a row. Otherwise, you hang in there. Okay, give me a number. I don't want to pick on anybody.
I'm gonna guess 6.
Pretty good. Anybody want to try something else? It's a lot easier to come in after somebody, because you're going to be right. You go 6.1, right? If anything bigger than 6, you win. But this is average. This is average. So in other words, this is called the expectation. This is what you expect. In other words, if we repeated this experiment over and over again, what would be the average of all those times we did it? Okay. When I say did it, the experiment is 1 year after another until you go bankrupt. Okay. Somebody give me another. Give me another one. 6. This is your chance to be a hero, See if you have it. Was there a song? We don't need another hero. We do need a hero here. Nobody wants to.
I'm thinking 6.25.
I knew you were going to do it. I knew you were going to go higher, because that wins the money, right? Okay. So okay. Now let's compute it. Okay. Now the computer science majors, this is your time to show your power. Let's draw a tree of the possibilities, okay? This is a probability tree. So we start here. You just opened your business. What are your 2 options? What are the 2 things that can happen? There's 2 choices. After your first year, what?
Get a good review or a bad review?
Well, it's not review. It's the bottom. We're talking cash here.
A year, sure.
You're going to actually, when you do this, you're going to do something in a way that it's very unstandard, okay? This is technically Markov chains in the end of the book, but I'm showing you a way to get there without knowing having to know that. Okay, what happens now? What happens now? Well, if you go down this line, you're out of business. That's a terminal node, okay? It's a terminal node. It doesn't continue beyond there. You have 2 bad years in a row. What if you go this way? What if you have a good year? What if you have a good year? How long would you expect to stay in business?
It's the same as the beginning.
Right. But how? It's like you start over again, right? It's coup de torsion. It's over, right? However, it's going to be what? From here, it's E. It's the amount of time. But however, you started with these 2 years already. So you're dealing with E plus 2 here. E is how long you expect to stay in business, but it'll be however long it takes, but you have these 2 initial years before. What about this right here? Well, by the same token, what will this be? You're starting with a good year, so it's like reset the clock. That'll be E plus 1. Okay, do you understand why this is E plus 2? It's the amount of time you expect if you're in this situation having a good year. That's E, but you've already consumed 2 years there. So the amount of time on the average you'll be from here down will be that E plus the 2 years that led into it. It's logical. You just have to think about it, okay? Okay? So 6.2, 6 years. Keep those things in mind. Keep them in mind. How do we solve this? Okay, you might say, what are we doing this for? Well, you know that I like the balls and bins problems, okay? You got to think this way if you're going to do a non-trivial problem of that type. So this gets back to standard stuff. But what's the genius of this? So E equals what? E, that average time will be what? Well, 40% of the time you're over here, right? So 40% of the time, what is your situation? You're at this juncture right here, right? So then if you're here, 40% of the time you're done. And how long did you stay in business? How many years? 2, right? And then 60% of the time, you do what? It's E plus 2. Now, 60% of the time you're in this situation, and it's E plus 1. Let me check my notes real quick for the time.
So my internet service provider kind of kicked me off. What is E? What's happening? What did I miss?
E is the expected number of years, the average number of years you expect to stay in business. If a bad year is 40%, a good year is 60%, and the only way you go out of business if you have 2 bad years in a row. Okay. I mean, that's a lot. I don't know how long you were disconnected.
The entire time.
Oh my gosh. I don't know what to say. This is hard to explain. Okay. This is some sort of recursive type thing going on here. But anyhow, what we did is we made a tree of the different things that could happen. So you started anew when you opened up your business, and you had a 40% chance in any year of having a bad year, and a 60% chance of having a good year. And then we followed these down. So if you just completed your first year. Now, the next year, if it's bad, you're done. And that means that if you went down this line, then 40% of the time you get 2 years in business, and that's all. If you go down this way, you're starting over again, so that's E, but you've already used up 2 years, so that's E plus 2. That accounts for this.
I think I see what's happening. That's interesting.
Okay, let me ask Aim then to see if she's still
Well,
with
if anything, I might just say E is the expected number of years you're in business.
Yes,
So
yes.
the number of years you're in business is that.
Yes, the expected, right. So do you see something about how we could solve for E? I mean, you did this when we did the conditional probability.
I mean, I see it. There's only one variable. We can solve it.
Okay, there the teacher clicks in there, the future future professor, let's say, I think so. So anyhow, so it clicks in. So
Yeah, it's
you see
just
that?
algebra now.
Yes, but it's not trivial because it uses decimals. And I've been embarrassed to tell you guys that I don't calculate with decimals. I use fractions. So when I have decimals, I get all mixed up. So anyhow,
Well, we could turn those into like tenths or fifths.
well, tell me how to do it. So E is what? It's 0.4 times what? What's this? Is that 0.8
Yeah, 0.8
plus 0.6 E?
plus 1.2.
I think so. And what's
Yeah.
this? 0.6 E?
0.6 E plus 0.6.
Okay, well, you guys are better at decimals than I am. How did you get those skills?
Computers, I guess. I don't know.
Okay, so let's keep going here. I don't know what the best way to do. Should I what is this? That's 0.8 plus 1.2. How much is that?
2.0.
Ooh, so 2 times this times is 0.8.
So it's 0.8.
Although you can't get what you already know. That's 2 times 0.4 is 0.8, right? Plus how much E do we have here?
Looks like 0.24.
Okay, and and I didn't really change anything over here. Stop me if I do something dumb. So E, let me get all the E stuff together. So E of what? So E times 1. I don't know if you can see all the way over in this corner. I never write over here. So it's E times what? 1 minus what? I think
Wait, what do you mean 1 minus something? Oh, I get it.
This is not good, you guys. I think I've made a mistake with the.
No, it's okay. I think you got it. E times 1 minus 0.3. I think it's 0.3 on the right. So.
I don't know, man. I think I forgot to multiply by. So this. Okay, we did that. I'm just double checking here. So you have a 0.8, right? 0.8.
Yeah, that 0.6 and get 1 point.
1 point. That's good. That's correct. So that part is okay. That part is what we agree is 1.4. I'm okay with that. But this E business.
Well, it ends up simplifying to 0.3 E on the right.
It's 0.84, right? So minus. Is that right?
Or did I? Oh, I thought it was 0.06 E. Whoops. Yeah, it is 0.84.
So let's see if we can get an answer out of this for what E is. So E equals, this is, I'm trying to remember what we guessed. You guessed what, 6 years? And AIM guessed 6.25? We're getting close to the answer. So what is it? 1.4 over what? What is that?
Or 0.16, I think.
Right. What's the answer?
0.75.
Okay. That's close, but no cigar. No, I'm kidding. That was so
No, it's fine.
okay. To me, this is interesting stuff because you have an infinite sample space, something that's hard to grasp, but if you write it in this sort of recursive way, then it becomes clear. And we did a problem like this before, right? We had this conditional probability thing where we were thinking about the same kind of idea. This is a powerful idea because you are reducing something infinite into just a couple cases. It's not a lot of cases into 2 cases. It's like infinite number of cases into 2 cases. And
It's so funky that you can do that.
But it works. It works. And I'm actually a couple of my colleagues. I showed them this, and they were surprised and said, "Well, you got to do Markov chains. You got to use matrices." Well, no, not really. Not really. And it may even be possible to use conditional probability with this to do just like we did before. If somebody shows me that, I may give them extra credit. If you can do this, in the, what should I call that? If you can put it into the framework of conditional probability that we've been doing. But notice this is not a probability calculation. This is an expectation. And expectation is usually a lot easier to deal with than probability.
That probably has something to do with that whole algorithms being complicated to find probabilities thing. Because we can analyze the complexity of them, of algorithms, fairly easily. But as you were saying, the probabilities is really hard. So it's probably because when you analyze the complexity of them, that's just the expected time it takes to compute them, right?
Well, actually, okay, you haven't taken the algorithms class yet, right? The 482?
Which one?
Comp Sci 482?
482, no.
The authors in the textbooks, and I'm saying more than one, textbooks say that worst case is sufficient for the day. That's what they say. And look, I mean, these guys are like at Cornell and MIT and stuff like that. I take their word for it. So when I think about algorithms, I invariably think about controlling the worst case, minimizing the worst case. That's my only thought. But if you wanted to look at average case, to me that's so hard that I don't know if the reward would be worth the effort. This is to me, the reward here is definitely worth the effort because if nothing else, this you could think of this as like a finite state machine because you're in when you come to here, you're in the same state you were when you started. You can think of, what I mean? You can think of it that way. And then you can use your linear algebra skills to find out what eventually happens by multiplying the matrix. So this is sort of a lead-in to Markov, finite state machines, if you want to think about it that way. Okay, so any question on this? Maybe I should be clear on what you guys should be doing. Chapter 4, it's most of the beginning stuff is pretty easy. So I would sink into that because when I make up the test, and I will promise you, I will give you that test before the break, and I'll give you a week after the break to work on it so you can turn it in. What I want is for you guys to be familiar with the basic notations, of chapter 4. And we've already done everything, but the expectation, this is critical that you go over there. They have some trivial, not like this. This is sort of a complicated example of expectation. They've got some trivial examples of expectation in chapter 4, Ross does. Please work through those. Please understand what he's talking about. It's almost too easy. You might wonder, why is he doing this? He wants to make sure you understand the definition of expectation. And I haven't even given it to you here, but I feel like I want you to read it first before we talk about it. As far as the test, there'll be some problems, maybe something like this. There's a problem, we did balls and bins, and there's a problem, the classic one that says, how many tosses throwing the balls into the bins do you have to do before you've got at least one ball in every bin? You understand that's different than what we did before. How many, suppose you have 6 bins. How many balls do you need to toss randomly before you expect to have at least one ball in every bin, one car in every garage? It's like a politician. Thanks, Abe. So that's the answer to that is spectacular. By the way, is totally unexpected. The answer to that question is a mind bending. Okay, it's mind bending. But then there's this very much more complicated problem. How many balls do you have to throw into like 6 bins before you expect to have at least 2 balls in every bin? That is a ridiculously hard problem, okay? Ridiculously hard. Ridiculous. But it's something we train, right? It's like you're working out. You exercise and you train to get better, right? So that's the kind of thing you cut your teeth on something like that. Then something like this seems trivial, Okay. Any comments, concerns? I guess there was a question about the test, about the partial credit, or Aim, could you fill me in? What were you?
Well, about the next test, when are you planning on emailing or posting it on
I
Canvas?
would like to do it before Friday.
Okay, fantastic.
I would like to do it. I may be missing a couple of problems, but I think at least I'll put a draft in your hands so you know what, some of them will be fixed. I think, I don't know, do I have posted up the old test from last semester? I don't know. That would, under files, I don't know. You're welcome to look at any of that. If it's in there, I tried to post it up. Did anybody look at my midterm one from last semester? No. It should be, when I exported the page, into the new page, they should have carried all the files, but the problem is they don't put them in order. You'll have to sift through. But that would be a good resource. And oh yeah, I remember something about grading the test, that there was a problem that a lot of people checked, and the check guys got it wrong. And I don't know how they did it. How they blew it. I don't.
We kind of told you that we looked it up. We did look up something it just happened, and an online answer was wrong, and we could prove that it was wrong. So that was kind of satisfying in a way for us. It's like, well,
when you told me that, I interpreted it differently. I interpreted that they got the right answer, just in a way that you didn't think was logical.
No, it was genuinely wrong.
Well, that means that you need to email them and say, I can offer my services. I do better than you. My hourly is just like lawyers, man. The cheapest lawyer is $400 an hour, $500. Yeah, hourly is $500. So, yep. All right, you guys. What time is it?
1:48.
Already a little overtime.
You guys have been very nice. You should just say it's time to go on. I don't know. I don't like wearing watches unless I'm working out, and it's never a good result because I'm always slower than I think I should be.
Mm-hmm.
It's this stupid stuff. Somebody rolled down there. I was jogging. I jog so slowly, it's pathetic, but I'm old, man. Somebody rolled down the window and said, "You move like old people." I couldn't believe they said that. They don't even know me. They did a Richard Pryor on me. It's like, and now it's like, now I just walk. I'd rather just walk. That's what happens. Eventually, everybody that jogs. I'm sorry, you guys. I'm telling you what old, being old is like. Everybody that used to jog starts walking, and they walk fast at first, and then they slow down, but they never ever go back to jogging. I don't know what it is. Your body just, there's no spring in your, unless you put shoes with spring. You cheat. You can get shoes with spring in them. They're like $500. That's cheating. I bet you don't know about those shoes, right? They have built-in springs. They look really weird, but you go a lot faster. Because you what do you call it? Reconstitute your force.
Yeah, that's funny.
You have to be old to know about that. You guys don't even know about that, Maybe you do, But,
no, I had no clue.
But you know about Richard Pryor. Say that's funny, You know things. You know some things, but not others. God, that's so. I don't know. I refuse to jog in the city now. I'll go on the hills and nobody, make fun of my jogging speed. People walk faster than I jog. All right, you guys. I'm having too much fun, so I'm not letting you go. You're welcome to depart.
Mm-hmm. I'll see you later.
All right, you guys. So remember what your homework is. Read chapter 4. Don't let me down,
Okay. Thank you.
All right.
Bye.
Nice seeing you.
See you Thursday.
Yeah, if you have, I got time right now. If you want me to go over a problem that you...
It was more like I got an email from a group member that just asked, hey, did you get a copy of the test with comments? Because we didn't get everything right, and they just wanted to kind of look over if you had comments. And I just had to say no. All we got was the numerical grade.
Yeah, I'm sorry. I was in such a rush to get it back.
I mean, it's fine. So I'm just gonna. I mean, if they want,
I could do it right
class,
now.
I'm
If you
just
want me to
gonna-
look, I could take a look at one of the problems. You know,
I don't know what problem my group member wants to look at. Like, I'm fine.
I broke it down into how much credit I gave.
Yeah, I know, and I was able to tell the group member this is the one that we didn't get completely right. And honestly, it's the same one that we talked about in class. We just nobody caught the fact that the situation from part A to part B changed a little bit.
Oh, yeah.
Well, it happens. Big deal. Like that's part of the reason why I'm glad there was extra credit on the test.
Yes,
So,
that's why I
yeah.
put it answer. Yeah.
Mhm. You know, like those kinds of things happen, and extra credit just kind of mitigates, you know, for that. So I'm fine. Like I know what we did, what happened, and what we got wrong. I don't know if I'm just gonna email my group member and just let them know, hey, just